Hello everyone. In this video, we're going to go through 9E, the chain rule. You've got in that little box some theory about the chain rule, and when I read through it, I'm like, this is just going to sound a lot more complicated than what it actually needs to be. The chain rule is not difficult. Out of the chain rule, product rule, and the quotient rule, it's probably the most straightforward. And we're going to do quite a few questions. So the real bit of theory you need to know is probably this. This would be the chain rule. You don't have to worry about the other notation. This is probably, going to be the most straightforward way of using the chain rule. So what we do is we let u equal the function inside another function. So usually it's represented with brackets. So you can see in question 1a, we're going to let u equal just that part inside the bracket, okay? And in b, just this part inside the bracket. And we're actually going to be using the chain rule for other possibilities as well. Let me just see if there's any on this page. No, so like if you had the square root, then that is also the same as to the power of a half, okay? So I think actually over the page, no, that's 9F. Okay, let's just get started in doing some questions here. So when you're using the chain rule, so let's just do 1A over here. We always look at, okay, think about a composite function. So what are you taking to a power? Okay, so if we were to expand this x squared plus 1 to the power of 4, it's going to take us a very long time to do. Okay, so it's not a quadratic that, will probably take less than a minute to do. To the power of 4, you've got this bracket multiplied by itself 4 times. So it's going to take a long time to do. And you don't want to do it like that and then find the derivative of each term. So we use the chain rule. So and it's what I'm writing is what you would write too. So let u equal x squared plus 1. What is inside the bracket? And then we're going to take the derivative of u. So that is what du dx is. So that's going to give us 2x, and the 1 becomes 0. So du dx is equal to 2x. Now, our function, let's think of it as y equals u. Remember, I let u equal x squared plus 1. So it's y equals u to the power of 4. So instead of having, let me just unhighlight that so you can see. So instead of writing x squared plus 1, because I let u equal x squared plus 1, I can rewrite my expression as y equals u to the power of 4. All right, so what I've highlighted in blue, it's the same thing. All right, so dy du is equal to 4u to the power of 3. All right, so we're just taking the derivative of u to the power of 4, which becomes 4u to the power of 3. And then we can substitute u back in. X squared plus 1. And then that's to the power of 3. Now, what I have found, and let me just unhighlight this. Okay, we have found dy du. Okay, that's what I just found. And du dx. So to get dy du, sorry, not dy du, dy dx, I just let them multiply each other. So it's the product of dy du times du dx. And when you think about it, if we were to multiply them, these du's actually cancel out and we're left with dy dx, okay? I'm not going to leave them crossed though. All right, so dy du is 4 x squared plus 1 to the power of 3 times du dx, which is 2x. Now, it doesn't matter because you're multiplying which one you put first. I would actually put the 2x first because it's a little bit easier to see what you're multiplying. So 4 times 2x is 8x, x squared plus 1 to the power of 3. Okay, so that is using the chain rule. Now, if you want to check using your calculator, remember, you can just go to interactive, and I always forget which one to go to. All right, calculate diff and put your expression in. Plus 1 to the power of 4. All right, just make sure everything else is correct. All right, and there's your derivative there. So you can see we got the same thing, which is always good. Oops, I forgot to put the power of 3 on there. There we go. Put that up there. All right, so the chain rule, right? You're just letting u equal usually whatever is inside the bracket. All right, let's do another one. Let me think of an easy one. All right, let's do D, only because sometimes we find it difficult when we don't have a bunch of numbers. All right, so ax plus b to the power of n. All right, so we're going to identify u first of all. So u is equal to ax plus b. So that means du, and I'm running out of room. My computer's getting a bit glitchy, so I'm hoping it's not going to get cranky and freeze on me. All right, so du dx is just going to be x. Oh, no, it's not. It's just going to be a. What am I doing? Sorry. A. The derivative of ax plus b is just a. And then remember we let y equal u to the power of n. So dy du becomes n times u. And then we're going to have n minus 1. All right, so because we don't know what n is, we do know that we subtract our power by 1 when we're taking the derivative. So it's just got to be left as n minus 1. All right, so dy dx becomes du dx times dy du. I'm just going to do it in that order. So a times n times u to the power of n minus 1. Oh, I forgot to substitute u back in, so let's do that. So in the previous example, I did that earlier, but I can do that now. So ax plus b, n minus 1. So your final answer shouldn't have u in it because you let u equal something else, and then you've got to substitute it back in at the end. All right. Let's do one with the negatives. It's just the same thing. All right, let's do g because g looks a bit tricky. I'm all over the place here. All right, so we've got x squared minus 1 over x squared to the negative 3. Now, if you ever have a base on your denominator, like we do here with 1 over x squared, just rewrite it as x squared minus x to the negative 2. All right, so that's the same. So x to the power of negative 2 is the same as 1 over x squared. So it's in the negative 3. All right, so let u equal x squared minus x to the power of negative 2. So we're going to find the derivative of that. So du dx. So it's going to become 2x. Now we're going to have negative 2 is going to come out. So it's going to be minus negative 2x. And then we're going to decrease that power, so it becomes negative 3. All right, so let's just tidy that up. 2x, and that's plus 2x to the negative 3. Okay, so just be careful when you're decreasing your powers, you don't accidentally increase your power. All right, so that's du dx. So let's do, so that means y, I'm going to do y du. So y is equal to u to the power of negative 3. So dy du is equal to negative 3u to the negative 4. And you can substitute u in here or at the end like I did in the previous one. X squared minus 1 over x squared. You should really write your powers as positive. So you can see I've rewritten that as 1 over x squared. All right, this looks mighty complicated. So dy dx is equal to, now notice you've got two terms here, so you've got to put it all in brackets. So 2x plus Now I should really write this as 2 over x cubed. All right, so not with a negative power. And then we've got, oops, not a bracket just yet, times negative 3. And then I've got a power there as well. So negative power, sorry. I'll just change that. So I'm going to put the negative 3 up here, and then x squared minus 1 over x squared to the power of 4. And let's just tidy that up. Gosh, this looks messy. All right, so negative 3, 2x plus 2 over x cubed. So that's on your numerator, and then on your denominator, we've got x squared minus 1 over x squared to the power of 4. All right, let's do one more example. So let's have a look at question 2. All right, so we're still using the chain rule. I'm just trying to think of which one to do. Let's do C. Gosh, where am I going to actually do C? In the corner over here. So 2C. All right, 6x cubed plus 2 on x to the power of 4, it looks like. Scroll up and make sure. Okay. All right, so I'm going to rewrite this. So we've got the x on the base. So this is the same as 6x cubed plus 2x to the negative 1 to the power of 4. All right, so let's let u equal 6x cubed plus 2x to the negative 1. So du dx is equal to, so 6 times 3 is 18, so 18x squared. And then 2 times negative 1 is negative 2. And then we've got to decrease that power, so it's negative 2. All right, y is equal to u to the power of 4. So dy du is equal to 4u to the power of 3. And then you can just substitute u back in. And I don't think I'm going to have enough space there. So 4, 6x cubed plus 2 on x. And that's going to be to the power of 3. All right, so dy dx, and I might just write dy du here because it looks like that equal sign is not matched up, and I didn't write du. So we're going to do dy dx. Now, because we've got multiple terms, just put them in brackets. So we're going to have 18x squared minus, I'm going to put that on a fraction, so just that. All right, so that's the same as 2 over x squared times 4. Now, I probably should have done this all in one go. X cubed plus 2 on x to the power of 3. Yeah. 4. Probably wasted that times on that previous line, but that's all good. Cube plus 2 on x cubed. You could multiply that 4 into that first bracket, but I'm just going to leave it like that. Yeah, it wouldn't really make any difference if you multiplied it in. All right, so that's the chain rule. So just recapping, all right, you just let u, in this case, equal the bracket. All right, and then you're finding du dx, then dy du, so you write y in terms of u, and then you multiply. All right, so I'm going to leave that there, and then we'll do 9F.